You step on the gas, your speedometer shows miles per hour or kilometers. Simple, clean, grounded in the world under your tires. But step onto a ship's bridge or into an airliner's cockpit, and suddenly miles vanish. The captain announces speed in knots. Why? Are we measuring rope? And why, with GPS satellites and digital screens, does a 17th century sailing term still rule the skies? The answer ties together a wooden log, a trick of the tides, and the actual curve of the Earth. Let's go back to the 1600s. No radar, no speedometer, no voice telling you you're drifting toward rocks. If you didn't know your speed, you couldn't guess your position. And that meant death by reef or getting lost until supplies ran out. So sailors invented something crude but brilliant, the chip log. Picture a pie-shaped piece of wood, weighted on one edge so it floats upright. Tied to it? A long rope. But not just any rope. This one had knots tied at exact intervals, 47 feet and 3 inches apart. Here's the ritual. A sailor tosses the wood overboard. It stays put in the water as the ship sails forward, pulling the rope off a spool. Another sailor flips a 28-second sandglass. While the sand falls, the rope runs through his fingers. He literally counts the knots whipping past. 1, 2, 3. When the last grain drops, he shouts, "Stop!" If 5 knots passed, the ship's speed was 5 knots. That's the literal physical origin of the word. But here's the deeper question. Why 47 feet 3 inches? Why not 10 feet? Why that weird number? A knot isn't random. It's geometry you can hold in your hands. On land, we use statute miles, 5,280 feet. That comes from Roman soldiers counting paces. Fine for roads, useless on open water. Sailors navigate by latitude and longitude, the Earth's own grid. The planet is a sphere, roughly. A circle has 360 degrees. Each degree of latitude splits into 60 smaller slices called minutes of arc. They decided 1 nautical mile equals exactly 1 minute of latitude. Genius. Your map and your ruler become the same thing. Need to go 1 degree north? That's 60 nautical miles. No calculator needed. Now bring back the rope. They calculated that if knots were spaced 47 feet 3 inches apart and they timed it with a 28-second sandglass, the number of knots passing equaled nautical miles per hour. The knot isn't just a speed, it's a direct line to the shape of the planet. So that explains ships. But why do jet pilots at 30,000 feet use knots? When aviation took off in the early 1900s, there was no pilot map system. The only reliable long-distance charts were maritime charts. Charles Lindbergh and other early flyers navigated exactly like ship captains, using stars, horizon, and the latitude-longitude grid. They used naval maps, so they used naval speeds. Plus, planes fly along Earth's curve. A New York to London flight arcs over the Atlantic. Using flatland statute miles actually makes the math harder. Knots keep the coordinates simple because they speak the same language as the globe. Cars measure miles from marching feet. Knots measure speed from the stars. Next time a pilot says, "cruising at 500 knots, you'll hear something deeper. Not aviation jargon, not a sailor's fossil, a unit of measurement tied to wooden logs, falling sand, and the very shape of the world we live on. Cars measure speed from walking. Ships and planes measure speed from the planet. If this changed how you see the world, hit like and subscribe to Exhaust Zone for more stories hiding in plain sight.